talking about function notation. Now, you may have seen this right here, and the way that you say it is f of x. Or like this one is r of x. So it's a way to denote what is the y and what is the x all within one function. So we're going to use this to help us to show a better way, other than just using x and y, a different way to write our equations. So the first example asks us to evaluate when x is -2 and 0. So that means that anywhere in this function that we see a -2 or an x, we are going to put a -2. So I can plug that -2 in where this x was right here and where this x was right here. So when I solve this, -2 plus 6 gives me a +4, which means that f of -2, so this function, when x was -2, equals +4. So we're going to do the same thing when x is 0. I'm going to plug in anywhere there was an x, a 0. So that equals 0 plus 6 gives me when this function, when x is 0, it equals a +6. So it's a way to show what your x equaled within your function. Instead of just saying y equals 6, it says this function, when x was 0, equals 6. So the same thing, let's do it again with this r of x function. So when r, with this function of r, when the x is -2, I'm plugging that in anywhere there's an x. And notice, this was a -x, or you could say it's a -1x. So when I plug in that -2, I have -1 times a -2, which is going to give me a +2. And then 2 minus 7 would give me -5. So within the function of r, when x is -2, it equals -5. So let's do it again now with 0. In the function of r, when x is 0, I have -1. I'm plugging in that 0 for x, minus 7. So -1 times 0 would give me 0. And then I know that 0 minus 7 would be -7. So in the function of r, when x was 0, it equals -7. Okay, let's look at the next example. So we're doing the same thing with, we're plugging in x when x is -2 and when x is 0. Okay, so we're going to do both of those. So within the function of h, anywhere I see an x, I'm going to put a -2. So when I solve this, I first see that I have -2 times -2. So that would give me +4. And I see I got now +4 plus 9, which would give me 13. So in the function of h, when x was -2, my function equals +13. Okay, let's do it again now with x is 0. So anytime I see an x, I'm going to put in a 0. Okay, I see first off, I have -2 times 0, which gives me 0. And 0 plus 9 would be +9. So within the function of h, when x was 0, my function equals +9. have a negative 1x. So I'm going to put that 1 in there so I don't confuse my negatives. Okay, so I'm going to start off by plugging in that negative 2. So anywhere I see an x, I'm putting a negative 2. So I always like to start with that multiplication because order of operations. So I have negative 1 times a negative 2. So that would be a positive 2. And then I got negative 1 plus 2. Negative 1 plus 2 would be positive 1. And then positive 1 plus 4 would be a positive 5. So whenever I have the function of n, and x is negative 2, my function equals 5. Okay? Let's plug in 0 now. Anywhere I see an x, I'm going to put in 0. Okay? So multiplication first. Negative 1 times 0 would be 0, so that kind of just goes away, and I'm left with negative 1 plus 4. Negative 1 plus 4 would give me a positive 3. So within the function of n, when x is 0, my function equals positive 3. All right, we could do it another way. So on this function, they're telling us that the whole function of h of x equals negative 7x. And then they're asking us, well, what happens when h of x is equal to 63? So they didn't tell us what x equals on this one. They're telling us what h of x equals. So I'm going to take this 63 and I'm going to replace that h of x with that positive 63. So 63 equals negative 7x. Well, in order to find what x equals, I need to solve for x. So if I divide by negative 7 on both sides, I get x equals negative 9. So what does that mean? If we write it how we wrote our last functions, this just told us that h, when x was negative 9, our function equaled 63. So either way you would like to write it is perfectly fine. That x is what we found is negative 9. Let's do another example. For m of x, 4x plus 15, and m of x equals 7. So they're giving me what the function should equal in the end. We have to solve for what that x is equal to. So I'm going to replace this entire m of x with that positive 7. And now I'm going to have to solve for x. So I'm going to first subtract 15 on both sides. And I get negative 8 equals 4x. And then I need to divide by 4. So x equals negative 2. So what this means is when we have the function m and x was negative 2, our function should equal positive 7. Okay, let's do our last example. When q of x is equal to 1/2 x minus 3, q of x should equal negative 4. So we're going to take that negative 4 and plug it in where the q of x is. So that gives me negative 4 equals 1/2 x minus 3. So I'm going to add 3 on both sides. So negative 1 equals 1/2 x. Then I see negative, or 1/2 is times x. to divide by 1/2. Now this is where you have to be very careful in your calculator. We need to type in -1 divided by a fraction. So I need to type that fraction in parentheses. 1 divided by 2, and I get x equals -2. So that tells me that when we have the function q and x is -2, our function was equal to -4.